we've turned our page, so we've moved our page over from a bunch of vocab, and we're right here. And I'm going to start with putting a line, and this is called a tangent. And it touches the circle at one point. So it might look like it overlaps, it's just bad drawing. Okay? But it's touching it at just one point. Now there are, I'm going to say 3 big parts of tangent lines that you need to know. First, if we draw in our tangent again where it meets at one point, it meets the radius at 90 degrees. So we're going to say a radius meets a tangent at 90 degrees. One done, one done. Okay. Another part, if we have a circle that has 2 tangent lines that meet at an external point, they're equal to each other. They're both x then. So tangents that meet at the same exterior point are congruent. All right. If we have a circle, it's kind of surrounded by tangents. So that meets right there. Call this A, B, C, and D. AB plus DC equals AD plus BC. Okay. Now we're going to look at the other side. We're going to add a couple of things about different types of tangents. We have internal tangents and external tangents. So see how they cross in between the two? We call that an internal common tangent. And then if we have 2 circles again, that's like an external common tangent. And we have, they look different sometimes. Like if you have 2 like this that are pretty much touching each other, let's say. That's an internal, even though it's just in between the 2 of them. If we have a circle with another circle inside of it, we can have an external. Okay, what about these? Where would their tangent be? Remembering that tangents can only touch at one point. There wouldn't be. There's none. No common tangent.
What?
We okay?
Yeah, I'm
All right. Now the one thing on here that is not going to be about tangents, we've got this. This is a secant. It intersects in two spots. Okay, so it's different than a chord. A chord stops like that. It would look like a segment. Okay, a tangent, as we've seen, touches the outside of the circle right here. But a secant goes through it in two places. Does anybody need me to move this around? We got this all down? Then we're going to take out our tangent packet, and I'm going to do some of the problems so that we feel comfortable about tonight's homework. Okay, I'm going to move this. Okay, we're going to try number 2 right here. So if we're looking, here, I'll just cover it up. I don't want to give away more than one answer. So if we're looking at geometry tangential practice, I'm going to do the first page. Okay, I want to be clear about this. The first page, front and back, is homework for tonight. So you just have 16 problems. I know it's in a packet, but packet didn't work out in a lot of my classes. So this page, front and back, all 16 problems are due tomorrow. Okay. We're going to start with looking at number 2. Now, if they are tangent, we're determining if AB is a tangent line. Okay? If we look at what we just did, we know tangents must meet their radii at 90 degrees. So, if this is a tangent, this would meet at 90 degrees. Do you guys see that it's now a right triangle? Yeah. Okay, so Pythagorean theorem will have to work for this to be true. So let's say 6.6 squared plus 11 squared, does it equal 13 squared? And we're going to solve both sides of that equal sign to see if it's true. So I'm going to take 6.6 squared, gives me 43.56, plus 121 equals 169. So 43.56 plus 121 equals 164.56. Does that equal 169? No. So is AB a tangent? No. So AB is not a tangent. Does that make sense? So you're just doing the Pythagorean theorem. Okay. We ready? We're going to look at number 6. There are 4 different sections of this homework, so we're going to kind of do one from each section so you get it. Wait, what's homework for tonight? The front and back. Good. That first page. Okay. Now let's read the directions here. This says, find the segment length indicated, assuming that the lines that appear to be tangent are tangent. So this is a radius. This is a tangent line. They must meet at 90 degrees. Do we agree that right here, 1.5, do we agree that's a radius?
Yeah.
Are any of our other lines radiuses?
No. Oh yeah. This one.
This one, right?
Yeah.
That's a radius. That's 1.5. Okay? So now we need to find this unknown. We still realize I'm teaching up front, right? Okay. This is my x. I'm just going to make it x. You could leave the question mark if you wanted. So I'm going to say 1.5 squared plus x squared equals, this is my hypotenuse, right? That's why it has to be equal all by itself on this side. What is this whole length going to be? 2.5. 2.5 squared. Do you guys think you can solve for x now? Find the squares of them, subtract, take the square root. Feel comfortable? Okay. Make sure you have that down. Okay, let's look at the back. Okay, I'm going to look at number 10. All right, the direction says, find the perimeter of each polygon. Assume that the lines that appear to be tangent are actually tangent. Okay, so we need to find the perimeter. So if we were to add up the whole outside, okay, so if this length from here to here, so this is like this that we learned in our circle book. If two tangents meet an exterior point, they're equal to each other. So if this is 13, this part right here has to also be 13. Okay? The whole length of this line is 25. So 25 minus 13 gives me this length from just here to here as 12. Which means this length right here also has to be 12. Okay? So this length from here to here must be 9.8. Good, because 12 minus 21.8 is 9.8. So this is also 9.8. This little piece right here at the end is 4.6, so this must be 4.6.
Wait, that's 4.6.
Yep. So we're going to go 4. Now I'm going to add up just these numbers. 4.6, 13, 13, and 12, because that's the same thing as adding 25, right? 12, 9.8, 9.8, and 4.6. I just circle them so I don't add the things in twice. I don't want to add parts twice. So I'm 4.6 plus 4.6 plus 13 plus 13 plus 12 plus 12 plus 9.8 plus 9.8 equals 78.8. That's my answer. How do we feel about that? You guys feel okay? It's a little bit of thinking of like what goes with what. All right, are we ready for 14? Okay, we're going to do 14. Now 14 is we're finding the missing angle. So we got to do a little thought process for these. Okay. So I want this angle over here, but I'm going to have to figure out all these other angles to figure it out. So this is what I'm thinking. Okay, if I knew what this angle was right here, I could say these are both radii, so these are all the same length, so these angles have to be the same length. And then I could subtract it from 180. Do you get my thought process? Let me say that a little slower because you know I talk too fast, right? These are both radii. So radii have to equal the same, both of the radius are the same. So that's base angle theorem for just this little triangle right here. Those two angles are congruent. So if I figure out these two angles and subtract it from 180, I would find my missing. Okay. This is 44 right here. This is a tangent touching a radii, correct? So that's 90 degrees. Okay, so I'm going to say 180 minus 90 minus 44 is going to give me that angle right there. 180 minus 90 minus 44 gives me 46. So both of these angles must be 46 down here. So then 180 minus 46 minus 46 is going to be my missing angle. 88 is my missing angle. How do we feel? Okay? So you're going to do the others, ones of these, for homework. And then we're going to do the next page tomorrow. And we're going to do that back page like during class. And then that next page is going to be the homework.